Welcome everyone. Today, we'll explore the complete sequence of the bright nickel plating process, focusing on the Watts-based bright nickel system. We'll cover everything from bath parameters to best practices, giving you a clear understanding of this important industrial process. Let's dive in. So, why choose bright nickel plating? The key advantage is its mirror-bright finish, which provides excellent leveling and a brilliant appearance. This makes it an ideal undercoat for decorative chromium plating. It also offers strong corrosion protection, especially when combined in duplex systems. Plus, its high leveling power fills scratches, reducing polishing needs. Finally, it's versatile, working well in both rack and barrel applications with modern additive systems. Let's walk through the complete process sequence. We start with soak cleaning using a hot alkaline solution to remove oils. Then comes electrocleaning, preferably anodic, to eliminate residual organics. Multiple rinses follow to ensure cleanliness. Acid activation removes oxides and prepares the surface. After another rinse, the core bright nickel plating takes place using Watts chemistry with brighteners. Post-plating rinses are essential. Optionally, decorative chromium plating can be applied, followed by drag-out rinses and drying to finish the cycle. Pre-treatment is critical for success. First, soak cleaning with hot alkaline at 60 to 85 degrees Celsius removes oils and soils thoroughly within 5 to 10 minutes. Next, anodic electrocleaning at similar temperatures eliminates remaining organics and smut, dramatically improving adhesion. Finally, acid activation with 5 to 10% hydrochloric or sulfuric acid removes oxides and activates the surface. This step is done at room temperature with a short dip, followed by thorough rinsing to ensure readiness for plating. Now, focusing on the bright nickel plating stage, the typical Watts-based chemistry includes nickel sulfate at 225 to 300 grams per liter, nickel chloride between 45 and 75 grams per liter, and boric acid at 40 to 50 grams per liter. The pH is maintained around 4.0 to 4.2. Organic brighteners and wetting agents help achieve the desired brightness and prevent pitting. Operating conditions involve temperatures from 50 to 65 degrees Celsius, current densities adjusted for rack or barrel plating, and continuous filtration with carbon treatment to maintain bath quality. Looking deeper into bath composition and conditions, nickel sulfate is optimized at 250 grams per liter, serving as the main nickel source. Nickel chloride at 60 grams per liter supports anode corrosion, while boric acid at 45 grams per liter acts as a buffer. Maintaining pH between 4.0 and 4.2 is critical. Temperature ranges from 50 to 65 degrees Celsius, with optimum between 55 and 60. Current densities vary by plating method, and brightener systems are proprietary but essential for leveling and brightness. These parameters ensure consistent, high-quality deposits. After plating, post-treatment steps are vital. Rinsing with at least 2 to 3 counterflow rinses minimizes drag-out and recovers valuable bath chemicals. Decorative chromium plating is optional but common, adding hardness, wear resistance, and final brilliance with thin layers. Final rinses with clean and hot water, sometimes using deionized water, prevent water spots before drying. Quality checks include visual brightness, adhesion tests like bending, thickness measurements, and inspection for defects such as pitting or dull areas to ensure the coating meets standards. Operating best practices help maintain process stability and quality. pH control between 3.8 and 4.5 is essential. Too low reduces leveling, too high risks precipitation. Continuous carbon filtration removes organic contaminants from brightener breakdown, with periodic carbon treatments restoring bath performance. Metallic impurities like copper or zinc cause defects, so dummy plating or purifiers are used. Proper anode management involves sulfur depolarized or carbon-type anodes in clean bags. Air agitation and continuous filtration support bright deposits. Finally, balancing carrier and secondary brighteners prevents brittleness and stress. To summarize the process flow, we begin with cleaning through soak and electro-clean steps, then activate the surface with acid and rinsing. The core plating step deposits bright nickel using Watts chemistry. Decorative chromium plating is optional, followed by rinsing and drying to finish. Critical success factors include strict pH control, continuous filtration with carbon treatment, balanced brightener systems, and clean anodes with proper bags. These elements together ensure a high-quality, durable, and visually appealing nickel plating finish.